previous speaker ran over by about 10 minutes. So Ray and I are going to give you a whirlwind tour of JBoss. And if you were at the keynote this morning, you'll know that, or hopefully you'll know that the term JBoss here, we're using it not to mean the application server, but to mean basically the middleware group in Red Hat. So what's going on in everything that we're doing in and around middleware in Red Hat, which, as you'll see, is a lot more than just the application server. Do I move this? Did. So, don't like this. Okay, so 11 years or so ago, when Mark Fleury and others created JBoss, there was a fairly new J2E spec out, and that was their focus. They created the first open source application server that started to conform with the J2E spec. And that's the logo, the far left as you're looking at it. Over the years, that space matured, and JBoss as an independent company matured too, and started to look at other things, including ESBs, portals, or rule engines, both by doing acquisitions of projects that already existed and by investing in these areas. And by the time we became a division of Red Hat in 2006, we had about 40 plus projects on jboss.org, and we were active in quite a few efforts off jboss.org, but we certainly had more than just the application server. Over the next few years, when we moved through JBoss and got more, through Red Hat and got more and more integrated into Red Hat, you can see, although we're still kind of a division or the middleware group in Red Hat, the logo changed, and we've had 5 application server releases since we were acquired by Red Hat. And in that time, in the last 6 years, the investment by Red Hat has been phenomenal, very, very significant. And those 40 plus projects that we had have grown to well over 100. Those are the ones that are on jboss.org or associated with jboss.org, and we're active in Apache and in lots of other communities as well. So what we were doing in 2005, although it was much more than just a J2E application server, now even that has been exploded. We're doing things with SOA, we're still doing things with Portal, we're doing things with BRMS, BPM, pretty much you name it in the middleware stack, and we're either already there or it's on our roadmap to be involved in projects that may already exist or kicking those projects off. So JBoss has come a long, long way in the last decade. So where are we today as a division, if you like, within Red Hat? Well, we've got lots of things going on. We've got, I really don't like the way that keeps changing. You can't see what I can see, but it's really off-putting. We've got many, many solution providers that we've worked with. We've got, like I said, more than just the application server. We've created our own user conference called JUDCon. That was kicked off a couple of years ago. It stands for the JBoss User and Developer Conference. We modeled that on FUDCon, and we've gone from only having one of those a year to now we're going to have like 4 a year. In the US, we had one in Europe. We're going to have one in Beijing very, very soon, and another one in India in January. The one in India at the beginning of this year had well over 1,000 participants, which for something that has only been around for a couple of years, I'm quite proud of that. And we're still number 1 in the customer support satisfaction survey for the 5th year running. So I think we're very, very healthy, at least trying to be objective here. I think we're very, very healthy. And we've tried to remain very, very close to our roots, which are open source. Like I said, 11 plus years ago, when Mark created JBoss, it was open source, and we've not gone back on that. That doesn't just mean that we're only involved in open source communities, but we're also involved in standards, and we're trying to drive standard participation in a very open way as well. So, we're involved in Oasis, W3C, etc. And also, critically, we're still very, very involved in the JCP, trying to keep various vendors, I won't name them, trying to keep them honest and push them and encourage them to become much more open source than maybe they are at this point. And to a degree, I think we're being successful. It's a long struggle, but I think it's a very, very important one that we continue to do. And in case any of you here missed it, earlier this year, Red Hat passed the $1 billion revenue from open source. It was actually something like $1.13 billion. And if you think about it, making over $1 billion from free software is quite a feat. And our next revenue goal is $3 billion, I think, by 2014 or 2015. Our model has changed quite a bit over the last 6 years, though. If any of you were using JBoss prior to the Red Hat acquisition, you'll know that pretty much if it was a project on jboss.org, we supported it in any combination with any other projects that were also on jboss.org and possibly elsewhere in the open source ecosystem. That worked okay when we were a relatively small company and when we only had maybe 40 projects. But the cross product of that support combination, as you explode it up, going to well over 100 projects, does not scale and doesn't work. So again, when we were acquired by Red Hat, we started to take more influence by what Red Hat had done and found successful with the RHEL and Fedora model. And this is pictorially trying to represent what's going on. We haven't got over 100,000 plus projects. I don't know where we got that number from, but let's say it's 100 projects. We try and take those and we make a cross-cut of those projects, and we funnel those projects at certain versions into supported products. So it'll not be every single version of the application server in a product that works with every single version of JGroups or Hornet Queue, etc. It'll be very specific versions. And that allows us to scale. We're continuing to do innovation in the community, so that's not going to change. So those projects continue to move at their pace, but the products move much slower because they have to do this cross-cut and they have to push all those projects through the productization phase. And again, part of this long journey over the last decade, the development space has grown incredibly diverse over the last few years, particularly over the last 4 or 5 years. Gone are the days when we were only trying to target servers or laptops and servers. Now, the integration is everywhere. Now we're having to target lots of different things. Cloud, obviously servers are still there, mainframes or your favorite PC. But on the far left, we're seeing a lot more requirements for mobile, whether that's phones, pads, or embedded devices like sensors. And this is influencing what we're doing, and it's influencing the problem space, which is what we're going to see soon, and I'll pick up after Ray's given the demo. Just to reiterate a few more things then, these are the slightly marketing slides. At JBoss World, Red Hat Summit earlier this year, we announced a new product, again to give you an idea of how things have grown. This is based on the InfiniSpan project. If any of you have looked at InfiniSpan, you'll know what that is. But basically, it's large-scale data grid with transactions. And given the model I mentioned earlier, what we've done is we've taken a version of InfiniSpan, version of App Server and some of its components, and productized that. So this is going to be our basis of our own entry into NoSQL. Obviously, we'll be doing other things with other NoSQL engines that are out there, but InfiniSpan is ours. And another one, the Drools project was acquired by JBoss when we were still independent back in 2005, and Drools has grown. It was a very, very successful project when we acquired it, but Mark Proctor and others have really continued to make it one of the most vibrant open source projects we have, and possibly one of the most vibrant open source projects that's out there, certainly in the middleware space. And it's forming the basis of lots of things we're doing with our SOA platform and in cloud and with the Business Rules Management Suite that's actually been out for well over a year. We put out a new version of this again at Summit. So those are my two obligatory marketing slides. I'll now hand over to Ray, who's going to give you an idea of some of the technologies that we've been working on over the last few years and show you them in action.
Fantastic. Thanks a lot, Mark. So today I'm going to give you a demo, and we'll walk through some of the architecture behind it, as well as some of the technologies. We're going to be taking some of these different solutions that Mark talked about, whether that's a business rules engine or a workflow engine, and have them out and deployed on top of the application server, Enterprise Application Platform 6. We also can easily deploy this out into the cloud. It's very, very lightweight, very, very quick. But the idea is that we're going to model a process, deploy it out, and have it execute it, be able to actually have pretty much a sales management system where we'll have a monitor that has real-time updates so that we can see how many sales are coming through, where sales representatives will put in whatever their order's in, and have approvals directly on mobile phones. We've done this demo before. We've had a lot of these cool cameras around, but you're just going to have to trust me on that. I'm just going to use some of the emulators that you can find within the JBoss Developer Studio to do so. And at the very last portion, we'll also be able to see where in a process someone might be. Now, all these tools are open source. They're not monolithic, very, very easy and quick to be able to pick up. So let me go and hop directly right into the demo. Yeah, it was great. I took the cab yesterday over here to Metropolis, and the cabbie was jamming away to Vanilla Ice at top volume. So that was my inspiration for a lot of the of what we're actually going to see today. Where is it? Come on. So right here in front of me, I have 3 different iPhones. I'm going to walk through the app first, and then we'll break it down into actual architecture. And if I go directly down to the bottom, you'll see a red one, which is a typical sales representative. In this case, that's Snoop Dogg. Purple is his sales manager. And we also have a vice president, so anything that's of high risk or value. Now, I'll walk through one set of the simple steps so you kind of get an idea, and then we'll break it down into actually how it works. So he's going to go and buy a Kindle. And we'll just place a quick order. Fair enough. If we go and click here, we'll be able to see that we have this brand new order from Snoop Dogg for the Amazon Kindle. We're able to approve it. And you saw some pop up in the background. We have an order that was just approved for X amount of dollars, since he is the only sales representative here. If we have large volume items or very, very expensive items, you'll see if we grab maybe an iPhone, something over $500, and we place an order, the manager still needs to approve it, but we might have more than one manager, one for the West, one for the East, multiple sales managers or store managers. That a vice president needs to approve something that's of high value. And so he'll be able to go and approve this or reject it. Pretty straightforward set of systems. And what you'll see is that we have some updates here on how many volumes of orders we might have. And this is all done through various different systems. And once I show you the quick high level, we'll go into each portion of it. So what you're going to see is that EAP is this large box on the bottom, or JBoss App Server. And we're going to be highlighting a few of the different technologies. To be able to use HTML5 and CSS3 to quickly have updates and to be able to push the widgets for the gears and have automatic on the real-time updates of how many sales transactions we're using AeroGear. We also are using Arai for the ability to be able to push back and forth. Some pretty cool things you can do with Arai. Arai allows you to be able to write in CDI and Java EE6, and it uses Gwit's cross-compiler to be able to take that CDI and literally push it out to the browser as JavaScript. You get full-time instant messaging between the two. It's a really cool messaging bus. And for the logic of a workflow, or for be able to determine whether we have a high or low risk, we're going to be implementing Joules. And so what I'm going to do immediately is jump right into the Drools portion. This is the JBoss BRMS, or known as Drools Governor. You'll notice that we have this authoring tool, which is based upon Google Web Toolkit, that allows you to be able to generate and author all sorts of different types of business logic. So by looking at a knowledge base, we'll see that we have information here, whether that's, let's just open up what we call a simple decision table, whether or not we're going to have a high risk or a low risk purchase. So anything between these conditions of the value being $0 to $500, we're not going to consider that a high risk, or we're going to consider it a low risk. Anything between 500 and above, we're going to mark that as a high risk process that we want the vice president to actually inspect and use. Pretty straightforward. You can actually give this to a business analyst to be able to fill in. Looks a lot like an Excel spreadsheet. Or you can use an Excel spreadsheet literally and have it uploaded into the system. Above and beyond that, you're able to model or directly hear your entire domain model dynamically, or give it to a business analyst, or upload your domain model from JARS. But what's interesting is how we've implemented JBPM5. JBPM5 has a real simple, straightforward process around this, but I'm going to create a brand new one just to show you an example of a process. Its notation is BPMN2, where we represent it. Oh, I suppose I should put a name in it, huh? Which allows one to be able to pretty quickly start with a particular different nodes or events. So I can just drag and drop a start node. Maybe I'd like to be able to add a task to that to ask Mark for a raise, and we can actually add a gateway onto this with different sets of tasks or conditions. Maybe he says yes. You know what? Maybe he might say no. And then we can actually even add an end state to the end of this. Really, really quick way to be able to generate this. If you actually look at the bottom, you're able to export this or actually get a representation in JSON or export it as a PDF or as a JPEG, et cetera, et cetera. But what will happen is that you're able to pass information into any given node. Resolution makes this a little bit tougher than I typically like, but we're using an initialized script to be able to invoke that rule that we set up with the decision table. And if I can push this out, we can see how we're going to be able to pass in which rule full group and actually give it the name of the particular rules that we actually might have. We're going through a review process, which is a human-based task, where we're going through a gateway if it's a high risk, which we can actually determine by if it exceeds the particular limit of those files. Then we actually assign it to yet another human-based task. There's a form builder within the governor and the repository. You can actually create quite a few different sets of assets. And eventually either we're going to ship it off to that customer, or we're going to tell them that their order was rejected based upon something that wasn't quite correct within the order. So relatively straightforward process. But what's really kind of cool is that I can start to monitor it. And I have a little robot here, which I'll fire off from a Maven script. Which allows us to be able to have a lot more sales reps, managers, et cetera, and we'll just start to sit back and watch the iPad automatically start to create some of these orders. So why don't we just create one of each right now, maybe two, and we have no approvers, nothing else. So they're going to have some orders that are going to start to create a backlog. And what we're going to do is start to not only just connect via RESTful services, but we're going to just start these robots that'll start to make some purchases. And we'll see that we're getting a backlog of quite a bit. We'll kind of stop that for a while. And maybe I'll start to add in one or two approvers right now, but no vice presidents. And we'll see some updates with the actual numbers. This looks actually much cleaner on a real iPad, but this is an emulator. And we'll see a transaction rate that's moving forward, as well as the backlog starts to immediately shrink. And now maybe we still have a backlog of expensive items. We'll start to push that. The actual rates of backlog will start to slow down significantly. In the meantime, you actually get real-time graphs with numbers popping up of how many purchases are going through. And I can take a look here, and I'll see how many are underneath review, how many are pending review of the vice president at real time. So if one of your customers or one of your managers goes on holiday, you're actually able to see where in a given business process you are slowed down, or where you might need to actually add some more people. And it looks like we've actually cleared our entire set of orders that we've put into the system, and we can even see how many we've gotten at this point in time of 173 for here. You know, I can actually start to stop the amount of vice presidents or turn it down to 0 and kick off some more purchases real quick. And numbers should be updated and reflected here of how many underneath review, how many, so you can get some real-time activity. And all of this, for up to this point, I haven't shown you a line of code. Well, pretty cool. So you're able to actually have systems that you can work hand in hand with your business analysts to create workflows and processes, to be able to monitor those workflows and processes. And this is all very, very lightweight. We actually have this demo up and running on OpenShift, which has memory restrictions and size restrictions. You can get it up yourself very, very quickly. And we actually have set it up so that you're actually able to clone a focus and be able to play with it on your own within setup instructions. This will be up in part of the deck where you can actually retrieve the information and poke around it yourself. But if you do want to be able to play with the quick starts themselves within JBoss Developer Studio, or if you're using Eclipse, you can pull down the JBoss Tools project. I can immediately go and grab and create my very own HTML5 application within seconds. It gives me a quick example. It's all based upon Maven. There's some very, very deep integration with Maven so that if I set up my particular environment, I can hand it off to the rest of my team and not have them waste a day or 2 or 3 trying to set up the exact same environment. It actually takes the dependencies and the facets you need and automatically generates it within the tool set so that you don't have to worry about sitting next to the guy for 3 days while he's trying to set up his environment. And you'll see real quick that I can go and create an example application with HTML5 that'll actually use RESTful services with REST Easy to be able to push information back into exposed RESTful endpoints that are CDI Java EE6 beans. And so bear with me for a moment. Got a lot of things running, but it's going into creating the project. And it'll be simple enough for me just to be able to grab it and deploy it and yank it off onto that running instance of EAP6. So as Mark was mentioning, right now JBoss has over 100 different projects. Java will always be important, and we will continue to be a leader within the JCP and driving many JSRs, but we're also expanding above and beyond the specifications. So areas like workflow, business logic, big data, these are all areas where you're going to see more and more evolution in more projects. Maybe you've seen Gavin King and Stefan Epardard's talks upon Ceylon, or Galder Zamorano's Polyglot, where we're talking about how you can actually run Rails-based applications, all on top of JBoss App Server. And we're still waiting. So right now it's going through and doing some validations on JPA and updating quite a bit of the information. And here we go. And what's nice is that we get a full, come on. A full application that's using jQuery and Backbone to be able to create apps that you can quickly use yourself with a set of quick starts so that you're able to walk through step by step each and every individual portion and deploy it yourself. But at a high level, That's what we've deployed in at our JBoss World keynote. It's a quick demo showing you how one can actually go and create applications using the BRMS. And we can even do things such as edit or view the given source so that you can check them in and out of GitHub. So very, very high level, very, very quick whirlwind tour of some of the other technologies within JBoss that we thought you might be interested in. I'm going to pass this over to Mark in one moment. And he's going to talk about the evolution of JBoss.
Very hot.
It is.
Okay, so Ray and I have both talked about how JBoss has been evolving over the last decade. There are a number of challenges that actually are for Java middleware in general, not specifically JBoss. And I want to talk for the last 20 minutes on what those challenges are and give you an idea of how we're trying to tackle them. If anybody's interested, there was a Middleware 2011 last year, had a special side conference called The Future of Middleware. All of those presentations and papers are available online, and you'll find some of the things I'm going to talk to mentioned in one or more of those papers. So, do a Google search for Middleware 2011. I think it was in Portugal, I can't remember. So the first thing that is a challenge, Ray's already mentioned this, is polyglot, and the sheer number of languages that are now out there. Obviously, there's cloud, which hopefully nobody in this room has not heard of by this point. There's NoSQL and big data. There's mobile. And kind of encompassing the last three, there's ubiquitous computing. This is a term that IBM and HP started to play around with back in 2000, saying that ubiquitous computing was here today. It wasn't really a reality back then, but as we'll hear later on, it pretty much is today, and that shouldn't come as a surprise to anybody. So like I said, there are a number of challenges. I'm going to talk about the bottom three for the rest of this presentation, so that's Java EE bloat, polyglot, and constrained devices. But the top two I'll just give a quick overview of now, and you will find these in the Middleware 2011 paper. The first is JVM and multi-tenancy. So, we hear a lot about the need for multi-tenancy, high density on cloud in platform as a service, but it's also a requirement on mobile devices. If you look at your phone, whether it's an Android phone or whether it's an Apple phone or possibly something from one of the other vendors, they're running apps. That's a multi-tenant device. Unfortunately, despite what we want and what we do in the middleware layers that sit on top of the JVM to make, for instance, AS7 be multi-tenant aware and be multi-tenant safe, if the underlying platform, which in this case is the JVM, is not multi-tenant, then it can all fall down. So the JVM today is not really multi-tenant aware. We need to see a lot more effort going into things like OpenJDK to relearn some of the things that hopefully many of us in this room learned in operating system classes, and things like red zone protection, being able to ensure that if you are running multiple independent apps in the same JVM, that the crash of one doesn't take down the whole JVM. If you go back like 30 years to some of the early PC operating systems, like Mac OS and even Windows, it was the case where an app crashed, took down the entire machine. But today, we don't live in that world, and we shouldn't live in that world for cloud and for mobile. If everybody had to, with their Windows phone, if anybody in this room happens to have a Windows phone and is in the minority, if an app on that crashed and you had to do a Control-Alt-Delete on it to reboot it, you would probably be very, very annoyed. So we need to see a lot more going on into JVM multi-tenancy, and we will see that. And we touched on earlier about big data and NoSQL. Despite the fact that, as I said, we've got JDG and InfiniSpan, it's not a done deal. You know, there's a lot of work going on in the likes of Hadoop and Cassandra and Infinispan and Neo4j and others. But NoSQL and big data is still an active area of research and development. You can see that by just looking at the latest paper from Google on Spanner, which kind of turns things around on what they were talking about only a few years ago. So there's a lot more effort that needs to go into this, and one of the areas that we're pushing, which is outside of the technical arena, is on standards. So we're driving standards in the JCP, but we're also going to drive standards elsewhere in this, because at the moment, NoSQL is a really good way of getting back to vendor lock-in, and you know, we've tried as an industry to move away from that over the last decade or so. So for the rest, there's always, for the last 10 years, this notion that Java EE or J2EE was very, very bloated. And you know, while that may have been the case, we've tried, JBoss has tried very, very hard to kind of get rid of that conception. We've made sure that you should differentiate between the standard and the implementation. There's nothing in the E6 specification that says you have to have a bloated app server. If you read it, you can have a very lightweight, dynamic, fast, scalable application server. If you want to implement something that's bloated, then feel free. It won't prevent you from doing that either. But what we did with AS7 and EAP6, which is the product version, is we went back to what we were doing with things like the microcontainer, and we re-architected significantly. We did that because we wanted to, like I say, get rid of this wrong notion that EE has to be bloated, but also because we knew at that point, a couple of years ago, that everything that we were going to be doing in JBoss, in one way or another, was going to build on the application server. Some people don't want to have a full EE6 stack. That's fine. We get that. And if we require them to pull in a really fat, if you like, app server, then it would be hard to convince them to use our app server. So that's why we re-architected a lot. And if you've downloaded AS7 or you played with EAP6, then you'll know that, you know, I think we pretty much accomplished that. When we put out AS7 initially, you know, well over a year ago, we ran a competition to find out how fast people could boot it on stock hardware, you know, not buying, you know, $1 million hardware rack from IBM, but just getting your standard laptop, see how fast you could boot it. And I think the fastest that people got it to was just over 2 seconds. And that was the full E6 profile. Oh, somebody tell me, less than 2 seconds. Below a second. The full profile? Yes. Yeah, see. When you're talking about sub 1 second, you're not talking about heavyweight and lightweight anymore. Everything is lightweight at that point. So, you know, I think we've accomplished that, and you know, we're going to build on that. You're not going to see us re-architecting the way we did for AS7 going forward. So the next problem that we need to address as an industry, and like I said, I'll show you how we're doing it, is the whole polyglot evolution. So I've been working in computing science, however you want to phrase it, for nearly 3 decades, and I've never seen or been involved in a period of time where there's been so many languages around. You know, 20 years ago, there was C was coming on the scene, we had Objective-C, but, you know, and Lisp was around and Prolog, but there really wasn't as big a language explosion as there is today. And this is the TOB index from September this year. Well, maybe some of you know what the TOB index is, but just don't take this as gospel, but just take it as 1 point on a graph. But you can see there's a lot of languages out there that are relatively popular. Obviously, you know, C and Java are still the top. My personal favorite, unfortunately, C++ is continuing on its decline. In 2009, I know the colors don't really come through too well on here, but that line at the bottom that kind of suddenly starts going up at an angle, that's Objective-C. So, you know, Objective-C, like I said, has been around since pretty much when C++ came out. The reason for that sudden increase has got to be pretty obvious. It's the whole mobile Apple iOS development. But we've got things like Ruby, Perl, etc. Still relatively popular, not as popular as Java and C at this point. Pretty much gone are the days where we can say there will only be a single language that people want to use, and we need to try and address that. So what we've done is we've admitted that polyglot is here to stay. A lot of those languages that I showed before, if they don't start on a JVM, it seems that quite rapidly somebody will do a port of that language to the JVM. One of the good examples, I think, is Erlang. So Erlang did not start on a JVM. It doesn't need the JVM. But somebody has done a port of Erlang called Erlang, and it's a pretty good implementation. What we've done is, obviously, because we're coming from the JVM background, we've decided, okay, there are going to be some languages that are off the JVM that maybe we can't help initially, but we're going to focus on some of the more popular ones on the JVM. And we want to try and embrace those communities. A lot of the communities that we're involved with are starting to have the kind of pain points that Java had when it first came out. So in '96, when Java came out, it didn't come fully sprung into life with a full J2EE specification, let alone a full J2EE stack. Those things came many years afterwards, and some people would say we're still evolving with the middleware stack. But these languages, whether it's Lisp or whether it's Ruby and JavaScript, they're starting to see some of the same pain points that Java had back in '96, the requirements for security, transactions, high performance, low latency messaging, etc. What we're trying to do is we're trying to get involved with these communities from the point of view of those communities. We're not coming in as Java guys and saying we know best and you guys just need to suck it up and take what we say. A lot of these groups, TalkBox, for instance, is like the poster child for what we're doing. For want of a better term, they go native. So several of the TalkBox guys were very, very ardent Java developers, and they've got involved in the Ruby community so deep now that they much prefer Ruby to Java. And they're building in those communities. They're educating those communities on how we've done things in Java and trying to provide layers on top of the Java implementations that exist for messaging, transactions, etc., in a way that makes sense for those communities. And the end goal is actually for us to be able to say to somebody running in JRuby, you don't even need to know that you're running on top of Java, that you're running necessarily on top of the application server. So just to quickly go through these, we've got a project called Immutant, which is doing pretty much what TalkBox has done for Ruby in the closure space. Salon is slightly different, so Salon is our own JVM language, and you can hear more about that, I think at 2 o'clock from Gavin King. So, like I said, Salon is a JVM language. The idea is eventually that we'll do a middleware stack of veneers and hopefully on top of most of what we've already got in Salon. It's running on OpenShift now. We've got a project called Escalante, which you may have been at Galad's talk earlier today, which is essentially TalkBox for Scala. Then we've got TalkBox, which is the brainchild of Bob McWhirter. And we've got other projects. So since we presented this at JBoss World, we now have a couple of other projects, one of which is as.js, which is basically JavaScript layered on top of the app server where you need it, or some of the components of the app server. The official pronunciation of as.js is asjazz. And we haven't got a logo for that yet, and I'm quite scared about what the logos for that might look like. What we're trying to do as well with Polyglot is understand that there are essentially two communities with the languages. There's the language community, the guys who are implementing the languages, those who are actually doing the salons or doing the JRubies or doing the closures, etc. And then there's the implementation community. What I mean by that is the ones who are writing the apps that sit on top of them, and they're the ones who may need messaging, transactions, etc., etc. We're trying to work with both of these where possible, and make sure that these languages are first-class citizens as far as JBoss is concerned and as far as the JVM is concerned. We don't want to just say, we're really Java guys and everything else is just, it's not really as important. These languages for certain apps, for certain developers, are more important than Java. So we don't want them to think they're second-class citizens. And sometimes that means that, where possible, we'll hire the guys who are working on these languages so that we can better empower them to continue to work in open source. So earlier this year, we hired Charlie Nutter and Thomas Anebo away from Engine Yard. So they're continuing to work on JRuby and continue to work in, like I say, in open source. It's not like Red Hat has this plan to turn it into a closed source project and become all evil empire on them. And we hired Douglas Campos and Bruno Oliveira, who are the two key guys behind a JavaScript engine called Dyn.js. And again, these guys are working in the language community, and some of them are also working in the implementation community as well. So Douglas is one of the key guys on the AskJazz project, along with Bob. So in order for us to address the polyglot issue and to also address some of the other problems that I mentioned earlier, as I said, we refactored and we re-implemented a lot of the application server. Not necessarily all of its constituent projects, but the core project, what you might know and love as JBoss AS or whatever it is that it becomes known as, we re-architected that a lot. And the idea is, it's all based on something called the JBoss Modular Services Container. And the idea is everything is a module, so still very similar to what we were trying to do with the JBoss microcontainer or the microkernel, if you go back far enough. But a given combination of these components at any one time can create a specific middleware stack or stack. So obviously Java EE is going to continue to be very, very important to us, EE6 and EE7 and maybe EE8, whenever that comes out. But by combining these in a different way, we have an enterprise mobile stack. So some of the stuff that Ray demoed earlier. Along the top are the different frameworks that we support. So AeroGear is the core mobile effort that we've got. Obviously that's a Mutant, and then we've got TalkBox and we've got Salon. The little dwarf there is the logo for a project called Cape Dwarf, which Alice Justin, if any of you, I think he's presented here before, but he's leading that. Basically, that's Google App Engine running on top of the application server. So if any of you are running GAE apps, and for one reason or another, you may want to bring them in-house, you may want to try them on your laptop, for instance, then Cape Dwarf's the project for you. Alice and the team have put a lot of effort into making that work seamlessly on top of the app server and also trying to make it work opaquely. So, moving on quickly, the last issue is this idea of ubiquitous computing, what people might call constrained devices. As I said, IBM and HP, so I was at HP back in 2000 when we were talking about this, they were coining this term ubiquitous computing, or at least using it, saying that processors were everywhere and we should be able to use them all and whatever, and they were even talking about clouds of processors. Didn't really exist back then. It does today. Here's an example. So we got a 68040 chip, 16-bit processor there, cutting edge back in the late 80s, early 90s. Here, from 5 years ago, is a 16-bit microcontroller that is more powerful than that M68040, has more processing power, can handle 16 concurrent input streams, and it costs virtually nothing. If you think about it, you've got much more powerful processors in your laptop than you had a decade ago. You've probably got a more powerful processor in your washing machine or your fridge. And people talk about these as though they're constrained devices. We were running EE6 stacks on chips that weren't that much more powerful than 68040. So they're not really constrained. And just to give you an example, here's a Pentium 3. So this was a Pentium 3, 1 gigahertz. I don't know how many of you were using computing 11 years ago, but this was cutting-edge technology in the heart of some of the more expensive laptops and machines that were coming out of HP and IBM back then. And I compared it against chips that were available in 2010. So, you can imagine where we are now 2 years later. There's a Nexus 1 Snapdragon, with the exception of floating point, which you can understand. The Snapdragon is beating the Pentium 3. As I said, fast forward 2 years, and the Pentium 3 is going to be much closer to the left-hand side. Constrained devices today are not constrained. We have a lot of power. We've essentially got what many people might have thought was a mainframe supercomputer in your pocket today. Hopefully, you've seen one or more of these devices. This is a Raspberry Pi. about $29. Again, more powerful than the laptop I was using 10 years ago. And there's a Beagle board, similar to the Raspberry Pi, cost $150. These come with Linux, and as I said, you might not consider them powerful today compared to Ray's laptop, which is still getting hot, or whatever you've got on your own desk at work or on your lap now. But they are very, very powerful compared to what we had a decade ago. And people are starting to use these for things that we may never have thought about, or certainly the guys behind the Raspberry Pi never have thought about. We really want to be able to help developers. So there are people who are developing things on Raspberry Pis where they want some of the things that we have provided in our middleware stack for years, like Hornet Queue, for instance. If we hadn't re-architected the app server, then it would be very, very hard for us to be able to help these communities. But like I said, with the AS7 re-architecture, making it more streamlined, much smaller footprint, and much faster, we were able to, and you'll have to take my word for it again because we can't do the demo, but we were able, on an unmodified Raspberry Pi with an unmodified AS7, full E6 profile running on that thing. So that's top. You probably can't see it very well, but the very top line says Java, and that was the only process that was running, and that was basically AS7. And I could show you the web page that we had, but it's a web page. It could have been from anything. Honest, we really did do it. But we couldn't have done that with something like AS6 or AS5. So these challenges that I mentioned, they're still challenges for us. They're still challenges for the industry. But I think we've tried very, very hard within JBoss and within open source to try and at least start to address some of these things. It's a road that's probably never going to end. But I think open source is probably the best place to start to address and try to solve some of these challenges before new challenges come down the road. I'll hand back to my erstwhile bald colleague to finish off.
So just a couple of points to recap. We also have a bird of a feather tonight at 8 o'clock downstairs, where we'll be talking more about the rename and what impact it might have on you. But otherwise, thanks so much for taking the time today. We're around for questions and answers if anyone does have any. And don't forget, vote.